What's the thinking that you do to come up with tangent of 5 pi over 6?
Well, 5 pi over 6 is 150 degrees.
I don't know about degrees. I'm unfamiliar with degrees. Can you tell me what that means in terms of radians? Okay, so which quadrant are we in?
The second one.
Okay, so if right here is 5 pi over 6, what is its reference angle going to be?
30.
I don't know, 30 radians is not correct. What would it be in
30
radians?
degrees.
What would it be?
What? 30 degrees?
Can you tell me in radians?
I don't know what that means.
So we don't know radians.
Right.
Okay.
Would it be pi over 6? Would be the
It
radian?
would be.
Okay.
So and I don't know if you caught this part or not. So 360 degrees is the same as 2 pi.
Yeah.
So
I know
this is
how to
our,
do that. I just didn't know what radians meant, but I know.
Okay.
I know how to do that.
okay, so you're okay with that.
Yeah.
So our reference angle now is pi over 6. Okay, now what are we going to do with that?
Do sine over cosine. Then?
Good. Okay, so hold on, I'm going to get there. So we're going to go sine pi over 6 over cosine pi over 6. That's correct. And from quadrant 1, we know sine pi over 6 is how much?
1/2.
And cosine is?
Negative square root of 3 over.
Good. So you got the negative sign because we're in quadrant 2 and cosine is going to be negative there. Terrific. How do you simplify this? How do you think to do it? Because there's a couple ways.
Multiply the 1/2 by the reciprocal.
So we have 1/2 times, and that's going to be a negative 2 over square root of 3. Okay, so that's going to become
Just 1 over square root of 3.
with the negative still.
Square root of 3 over
And
3.
we're going to have to rationalize that. So
Right.
that's going to become,
The square root of 3 over 3.
make sense? Okay, so on to 5 pi over 3. Can you walk us through that, Colby?
For the sine?
Yep.
Yeah, so in radians, that would be equal to, wouldn't it be pi over 3 in the first one?
Yeah, and which quadrant are we in?
Right now, since it's 5/3, we're in the fourth one.
Very good. So here's 1 pi, which is 3/3. 4/3, 5/3 is going to put us into quadrant 4. So there we are. And you said the reference angle here is going to be,
Pi over 3.
so that's what we're going to take to our quadrant 1 in this mental picture of that chart. And sine of pi over 3 is going to be,
Root 3 over 2,
and because we're in quadrant 4, it's going to be negative square root of 3 over 2. Okay? Okay, Sage rather. How about cosine of 7 pi over 6? Walk us through that.
So we would be in the third
Good.
quadrant.
So there's 1 pi, and then another is 1 1/6 pi. So what's our reference angle?
Would it be pi over 6?
Very good. So that's going to be our reference angle. That puts us into quadrant 1, and we know the cosine of pi over 6 is going to be,
That would it be negative the square root of 3 over 2?
exactly, negative because we're in quadrant 3, and cosine is negative there. Okay? Emily, you ready to give us a shot for tangent of 4 pi over 3? So first tangent is going to be what?
Sine over.
Good. And now let's see if we can figure out where 4 pi over 3 is.
And third quadrant?
Very good. So there's 1 pi, and 1 1/3 pi is going to take us down here. So our reference angle is going to be,
Pi over 3.
so that takes us into quadrant 1. So the sine of pi over 3 is,
Square root of 3 over 2.
good, and the cosine of pi over 3 is,
1/2.
good. And so how do you think to simplify that?
Multiply by the reciprocal.
Okay. So the 2's are going to cancel, and we're going to get,
Square root.
And now let's talk about the positive or negative sign. In quadrant 3, is the sign positive or negative?
Negative.
And how about the cosine?
Negative.
And if sine and cosine are both negative, the tangent is? There we have it. Make sense? Okay, how about tangent of pi? Pi, do you want to give it a shot?
Sure. So we know pi falls on the x-axis,
Good,
so wouldn't it just be the sine over cosine?
good,
So the sine of that is 0,
good.
and then over -1, so it's just 0.
Very nice. All right, Aaron, you ready for the tangent of 3 pi over 2?
So pi over 2 is 90, so then 3 of those places you on the x-axis.
Or 3 pi over 2.
Oh wait, sorry.
So where's that going to be?
The y-axis down,
Down. So we're down here.
which is just the same. So then the reference angle would be 0 on the y-axis.
And this is one we're not really going to think reference angle because it's not really, it doesn't make a good angle with the x-axis. Instead, we're going to think of it as, what's the ordered pair right here?
0, -1.
Okay, and then we know that the cosine is going to be the x value and the sine is going to be the y value.
Okay, so it's -1 over 0, which is undefined.
There you go. So it's undefined. Okay? All right. So, for the people on the video, we're going to have a redemption quiz on Monday and Tuesday next week. So the quiz that we took earlier on those 10 values of these known values of sine, cosine, and tangent, you're going to get a chance to replace your earlier quiz grade, which for many of us was not pretty, with a second shot at it. So even though we're testing Friday, where you're going to need to know these, we're going to need to know these not just for the test, but forever in future math classes, this one and others. So you still have to know it and you still got to remember it. So we'll quiz on that again Monday and Tuesday. If you do better than what you did the first time, which for many of us, we set the bar very, very low, we should be able to do better. Then I'll replace that quiz grade with the one you get on Monday or Tuesday. Okay? All right. So, questions on the homework? Anything you would like to see clarified or explained? And we're gonna review today, and I've got a final review for you today, but I thought we would kind of focus our attention today on the stuff that we're going to test on tomorrow. And then we'll get another final review on Monday, and we can talk more about their stuff going all the way back to the beginning of class as we need to. And we'll get a second review for the final on Monday. So this is our, let's end the year with as many tests as we can squeeze in. So we'll test Friday, we'll test a week from Friday, and we'll test 2 weeks from Friday, so that we'll end 2020 with a bang or something. Questions on the review? Yes.
I don't have like a specific number, but can we just go over odd and even?
Yeah, let's do that. So, so the question is odd, even, or neither. And so there are a couple ways we want to understand this. The first one is algebraically. So algebraically means I'm going to give you an equation, and then I want you to show me how you know that it is going to be odd or even. So what we're trying to get algebraically is that an even function has the property that when you plug in negative x for f, that is any negative number you plug in there, will be exactly the same as the positive number you plug in. So if you plug in -5 into the function, you get the same answer as you plug in +5. Plug in -2, it's the same answer as you get when you plug in +2. But we're not going to show that with just plugging a specific number. We're going to show it by plugging in any or every number. So we'll plug -x in, we'll do whatever arithmetic. If that turns out to be exactly the same as the original, then we're gonna say that that's an even function. An odd function has the property that when you plug in any negative number into the function, you get exactly the opposite of what you got by plugging in a positive number. So you plug -4 into an odd function, you get the same answer as -1 times what you got when you plugged in +4. And we're going to demonstrate that by plugging in any or every possible opposite number and showing it's the negative of what we got in by plugging that original. And then neither means neither one of these things happens. So these aren't mutually, I mean, they're not the only things that can happen. So let's pick an example. So we'll say f of x is, say, 5 minus 3x squared. So here's our function. And we want to say, is this even, odd, or neither? So what you will show, what I'm looking for, is we're going to plug in -x wherever we see an x. So in this case, there is no x to plug in. In 5, we're going to plug it in where we see that -x squared. Is that okay? Then we're just going to do what that does. Well, when you take a -x and square it, it becomes just positive x squared. Times the -3 is going to be still a -3x squared. Now, you look at this compared to where we started. They're identical.
Yeah, they're even.
So that means it is even. We have shown that f is even. Okay? If we do something like, say, f of x is 2x cubed minus x, and this is our function. So we want to test it by plugging in a -x. So that means everywhere we see an x, we're going to plug in -x, and then we'll just do the arithmetic, see what happens. So when you take a -x times itself 3 times, what you get is, and you multiply that by 2, what you get is -2x cubed, and the minus -x is plus x. Now you look at where we are compared to what we started, and hopefully you can see that if you factored out a negative, then you have exactly what you started with. That is, this is the negative of f of x. And you don't have to write this stuff unless I'm just using that for clarification purposes. You got to at least get to this point. And recognize that, in fact, when we plugged in a -x, we got exactly the opposite of what we started with. Therefore, this must be odd. Okay? And then if we get something like, say, f of x is maybe 2x squared minus 3, and now we plug in -x, because that's how we check. The way you check for odd and even algebraically is to plug in a -x. So we'll do that, and then we'll do the arithmetic. So the -x squared becomes times the 2 is still going to be that. And now you look at where we are. Hold it, I didn't want to do that. That was boring because that's exactly the same as what we did before. So let me do an x cubed minus 7. Okay? I'm not pointing out what I want to point out otherwise. So we're going to go here. Now -x cubed is going to be -x cubed. Is that okay? Now you compare this to where we started. Is it identical? No, so it's not even. Is it exactly -1 times the original? Not quite, so it's not odd. Well, that means it's neither. Neither even nor odd. Everything has to fit into one of those 3 categories. Now, do you want to talk about it geometrically, or are we,
I think I'm good.
you're okay on that? This, I think, is usually the hard part. Okay, Misha.
So I guess there was 19 on both of them,
Uh-huh.
where it's like suppose f of a equals 3b and f of 3a equals
Yeah.
5b.
Those are hard?
Yeah.
Okay, do you want me to do the one that's on there, or you want me to just make one up?
I guess we can do the one on here.
Okay. So they're telling us that f of a is,
3b.
and what else do we know?
And f of 3a is 5b.
And then we have a part A and a part B, right?
If f of negative a, wait, what is f of negative a if f is periodic with period 4a?
Okay. And then what is it if it's linear? Right? So you don't have to do this geometrically, but I think it's easier if we can visualize what's happening and talk about it. So let's just draw a picture here. So we know that f of a is 3b, and I don't know what a and b are, so I'm just going to make up something so we can see it. So I'm going to say there is a, and I'm going to say there is 3b. So there is f of a is equal to 3b is that point there. You okay so far? Then f of 3a, well 3a, I'm going to go over another couple a's. There's now 3a. And 5b is going to be 2b bigger than that. So I'm going to say there is 5b. Okay, so there's a visual. Here's a point that we know. There's another point that we know. That's all we know about this graph. What it does in between there, I have no idea. Maybe it's a straight line. Maybe it goes to the moon and back. I don't know. Doesn't matter. But if it's periodic and the period is 4a, that means every time we go a horizontal distance of 4a, we're going to get back to the exact same y value that we got at that previous point. If we go 4a from here, we're going to be back at that same y value. So in general, if I go over 4a from 1a, that will put us at 5a, and that's going to be back at that same height. We're going to get right back to where we were. If I go 4a from the 3a, so that would put us at 7a, then I'm going to be the same height that we were there. And this will continue in each direction forever. That's what it means to be periodic. Now, if we were asked, what is f of 2a, I got no idea. I can't answer that question because I don't have that information. If I was asked what is f of 4a, I have no idea. It would be the same as what I got for f of 2a, but I don't know f of 2a.
So then negative a would just be 2 over.
Ah, very good. So if I wanted to know what is f of negative a, that is 2a from here. I don't know that. But it is 4a from f of 3a. So it has to be 5b. Does that make sense? If I wanted to know, if I said, crazily enough, what is f of 41a? You can answer that question.
It'd be 3b.
And that was quick, and that is correct. Because every multiple of 40 is going to take us right back to where we started with. Another a from that is going to put us right there. So f of 41a is going to be the same as f of a. Therefore, it's going to have to be 3b. You got the idea. Does that make sense? Okay. So, we go down the periodic part. Now let's talk about the linear part. Now, there's a couple ways you can do this. You could call these ordered pairs, get an equation of a line, and do all that. I think, because I'm going to ask you something that's pretty straightforward. I'm not going to ask you what is f of 2a or what is f of 4a. So I'm going to just try to attack this visually like we did with the periodic. So if it's linear, that means that whatever, our delta x over, our delta y over delta x, or rise over run, is going to be the same as we go forward. So whatever rise over run this is, that is we went up, how much? 2b, and we went over 2a. So are we trying to find f of negative a again? So that's going to have to continue this way as well. So if we go over 2a, which is what we're trying to do here, we're going to have to go down to b. And so that's going to put us where? At 1b. So we'll get f of negative a is just b. Does that make sense? So the difference between a periodic and a linear answer. Yeah, fire away.
So on 28, there's a negative, you're graphing, there's a negative t,
A negative,
t value, like inside the parentheses.
let me take a look, we're on,
Sign, then parentheses, negative 2/3 t.
yeah, okay, 3, that was the negative is
Positive 3 sign.
3 sign, the
And
negative is in here.
yeah,
So what does a negative do inside?
it flips the x value,
Flips it in the x or in the y?
in the y.
Yeah, and in this case, you can't really go wrong because we know that sine is an odd, or we maybe don't know yet. We're trying to know that sine is an odd function. So here's our parent function for a sine curve, right? You can go loop above, loop below, and it would continue on and on in each direction. So if we reflect this, this means reflect in the y. So we are going to get, this is going to come over here, and it's going to come over there. But notice, because sine is odd, that is, if you hold your pencil on the origin and you turn it 180 degrees, it's identical. You get the same thing. So that also means that you can double reflect and get back there. If you reflect in the y and then take that reflection and reflect in the x, you get back to where you started. Which is saying that when you reflect in the y, you get the same thing as you reflected in the x. So an odd function has the property that a reflection in the y is the same as a reflection in the x.
So then, like if this is confusing, could I turn it into a positive 2/3 and make the 3 negative? Would that be the same?
Yes, you can. Because remember what we said when we were doing this algebraically. Here's where that's coming into play. We said what it means for a function to be odd is that f of negative x is negative f of x. That's saying reflection in the y is the same as reflection in the x. So algebraically, you can do exactly what you said. You can think of correctly as passing the negative out of the function out in front. And that works only with an odd function, which sine is. And so now if you want, you can just think of it as a reflection in the x, which is maybe more familiar territory. Curiously enough, what if we were doing this with a cosine curve? Just a what if. What if we had said this, we were trying to graph this?
What is this cosine?
I just have another question.
Oh,
When you have a midline that's not 0, so you have to like translate it upwards, can you still like just move the,
like what we're doing here?
yeah, can you still
Yes.
move the negative?
Because this, what happens here, the reflection stuff is going to happen before the translation in the order of operations. So yes, you can still pass it out there and then work on graphing from there.
Okay, thank you.
Okay, so what if we'd asked this question?
The cosine is even.
It is. Cosine is even. So what does that do? Remember what we said algebraically. When it's even,
If you reflect it across the y-axis, it's really the same.
yeah. So when it's even, we said f of negative x is the same as f of x. Or what Aaron is saying is if you look at our original cosine curve, it's symmetric with respect to the y-axis. So if you reflect this in the y, it's the same thing. Or what we said, if you reflect in the y, it doesn't change f at all. And so you would be correct to think of this in a way, because this is an even function, it just kind of absorbs that negative, and that is exactly the same thing as just graphing it without the negative sign. That's how odd even works. So the odd, you can pass the negative outside. The even, you can just absorb it or ignore it, or it just goes away magically because of the symmetry in the y-axis.
But then if it isn't centered on the y-axis, would you have to,
And that's what Katrina was asking before. Yeah, but remember, if we did something, so suppose I gave you something like 2 cosine of negative t plus 3 plus 5. The order of operations is, remember, if we're going to do this in pieces, we start with our cosine curve. What goes first in the transformations? You have reflections, stretches and shrinks, and you have translations.
Reflection.
So the reflection and the multiplication stuff, so any reflection or stretch or shrink, you can do interchangeably. They're going to happen before you do the translation part. So you would still say, because cosine is even, this is going to be the same as y equals 2 cosine of t plus 3 plus 5. The cosine absorbs that negative thing.
But like if it's starting not moving upwards but like left to right, since then this
Okay, let's make it simple. No, I get what you're saying. So let's not put so much complication. So let's make it say y equals the cosine of the negative of, and let's say x minus, say, pi over 4. So we'll try to keep it a little bit simple. Okay? Okay. So here's our parent function, our cosine curve. Okay? Now, how do you want to think of this? Which would you do first?
Well, absorb the negative. Just like
Or you could say, if you didn't know that you could absorb the negative,
Or
you would say,
redistribute.
first we're going to reflect it in the y. Okay, I did that. Right? Because reflection of the y leaves it the same.
well what else?
Then you're going to do the translation part.
So you ignore that like the x.
So what you don't do is translate it first and then reflect. Okay, now, and I don't want to confuse things, but suppose I didn't give you a cosine curve, but I just gave you a curve. So suppose we said, here is our f of x. Now, you know what that is. That's a parabola and all that stuff. Now, if I said graph y equals f of negative x. Now, if I was starting with a parabola and I said, what's f of negative x, it would be unchanged.
But it translated.
But this has already been translated. So it started, moved away. Now, if we reflect that in the y-axis, it is going to come over here.
Crazy, man.
Crazy indeed. But I mean, it's still consistent. I mean, the way we do this isn't like we do it different on different problems. You just got to kind of think about what's the order that you apply it in. Good questions. Good thinking. What else? What would you like to practice? Sage, pick one. Anything. It doesn't have to be a specific one. It can be a kind of problem if you want.
Evens and odds are not part of it.
Evens or odds are your Achilles heel at this point. Okay? And like what we talked about there. So shall we come to the board and do some even and odds?
I guess can we just practice the sine, cosine, curves and stuff?
That's still hard.
Because I have the even.
Okay. In terms like what you did to start class or in terms of graphic stuff?
Like how we started class.
How we started class. Okay? So let's do
Wow.
okay. I'm going to hand you out a final review A, which I have somewhere. I don't. Probably you don't want the AP calculus final review A. You can have those to keep. You might want to put yours on the fridge. Not sure that many of us will be putting that
I,
on.
I,
Yeah, well, okay. You probably don't want this.
I think it's not too gummy, because I have a bubble blower.
So we need a hard
Yeah,
copy
but-
of the 6275G. Somebody want a hard copy of the review from last time? Okay, those that don't have printers.
That's getting scared you a couple times up here.
A good weight to it, it's a little daunting.
I was like, why are they so pale? And then I realized it's because of chalk.
Yeah, turning into a ghost here.
Just come home covered in chalk every day. Your pants are all chalky too.
I know. I had a professor when I was in college, a math professor, and he would sit there and like on his lower lip, he would just kind of twirl his chalk when he was talking and thinking, just kind of absentmindedly. And by the end of the class period, he'd have this big white, like about the width of your finger, a white chalk mark on his lip. It was like, all period, I'm like licking my lower lip, like I just couldn't wait to see him lick that and be like, oh God, I got all that chalk. But he never did. It was amazing. He would sit there and just twirl it kind of contemplatively. All right. Sage, walk us through this.
okay,
4 pi over 3 is going to be where?
it's gonna be in the second.
Yeah, well, this is like 1 1/3 pi.
Yeah, so that would be, oh, sorry, third. I
Yep.
was looking at the graph.
Okay, so there's 1 pi or 3/3. Now we're down here. So what's our reference angle?
That would be 60 degrees.
I don't know
So
about
that
degrees.
would be pi over 3.
That's pi over 3. And so cosine, does it start big or small?
Starts,
So it's going to go 1, square root of 3 over 2, square root of 2 over 2, negative 1/2. Okay. Caden, what'd you get for sine of 11 pi over 6? Oh, you don't remember it?
I got negative 1/2.
Negative 1/2 is correct. And how about
I
the,
got the negative square root of 3.
oh, that was like in stereo. We agree, if both heuristas come up with the same answer, it must be, oh, that was Heidi? I'm sorry, it came from that direction. That's the third twin, is that what you're saying?
We just got a little confused.
Oh, okay. Testing tomorrow, 8 o'clock.
Oh, yeah.
What's that?
We thought we said for this test this week. So it'll probably work out if they have a physics test on like the day of the final or something.
Yeah, I'm getting that figure.